Okay, I'm going to see what I can get through of this now. Hopefully all. Okay, so the first thing is basically an issue of labeling. So I told you before with respect to segments anyway, that basically two segments are congruent if you could pick one up and move it to the other one. Congruence means like identical. It's just at a different place in space, but it's the identical object. So on this one, you can see there's three lines. That means A, B, and DE are the same length. These two angles are the same because of the single mark. These two angles are the same because of the double marks. These are the same because of the triple marks. This side and this side are equal because of two marks, this side and this side. So there's actually a bunch of different things that we can write, but this is written already actually. ABC is congruent to DEF. So what we can say is the measure of angle A equals the measure of angle D, which is that angle A is congruent to angle D. The measure of angle B is the same as the measure of angle E. The measure of C is the measure of F. And this wasn't written arbitrarily here because A and D are both listed first, they are equal. B and E are both listed second, they are equal. C equals F because they are written last. So it's got to be in order. You can say the measure of AB is the measure of DE. The measure of AC is the measure of DF. And the measure of BC is the measure of EF, which also means that the line segment AB is congruent to the line segment DE, and so forth. Okay, so now we're given congruence. We're given that triangle XYZ is congruent to triangle MNO. So which angle is congruent to Y? Well, Y's in the middle, N's in the middle, so it's angle N. What segment is congruent to NO? So that's the last two guys, so it's the last two guys, YZ. If angle Z is 4x minus 3, angle M is 13, and angle O is 5, so this means that also angle X is 13. This says also angle Z is 5. So if we look at what's relevant here, Z, 4x minus 3 is 5, 4x is 8, x is 2. So this part didn't even matter. We could have solved with this, we could have solved for angle N, and then we would have known everything about everything, but we didn't need to. We just needed to know x. Okay, so on these triangles, we're labeling what we know to be congruent. So we can see DE is congruent to CF. And remember, these can be listed in either order. So this could have been ED, and that could have been FC. Right now, we don't know which order those should go in. We see that well, let me stick to the right side. So DE was from over here. So let's do DC was congruent to EF. And because CE is its own line, CE is congruent to itself. And we can see angle D is congruent to angle F because they're both right. these two add up to 90, and these two add up to 90, so we can actually say that these two are congruent. Angle C congruent to angle E. Oh, sorry, I should be more specific there. DCE congruent to angle FEC. And then that would yield these being congruent also. So basically, the triangles have all the same sides and all the same angles, so I can say CFE is congruent to, and I have to make sure I get it in the right order. So FEC was part of this one. FEC was congruent to DCE. Well, and all, yeah. So F and D have to be in the same place. So FEC was congruent to DCE. So let's make sure this is right. EF and DC should be in the same spot in some direction, and they are. CF and DE and CE should be in the same position. CEEC, that's fine. So this appears to be correct. We could have written this all out, angle DCE congruent to FEC, and then we could have looked at it and said, you know, if I'm going to do this, I'll do this outside line first, FEC, and then I'll do this outside line first, DCE, and then we would have already had these in order. But that is how they ended up anyway, so that's fine. Okay, so this is just really vocabulary at first. Included sides and angles. So angle B is included between sides BA and BC. So here's BA, BC, and this angle is included there. Angle A is included between AB and AC. Sides can be included between angles. So AB, this one, is included in between angles B and A. So we want to name the included side for angle 7 and angle 8. Here's angle 7, and here's angle 8. So this is what's included. DS. SR SR is here. So it's included between angle 3 and angle 6. You could have really said it was included between these two as well, but we don't have a name for that one. We only have a name for this little one, so 3 and 6. The included angle for DR and FD, so FD and DR, the included angle there is 4. So included just kind of means the thing sandwiched between. Okay, so we're given that these two are congruent. So the question is, what can we conclude about their corresponding parts? Well, it goes A, B, C, D, E, F, so they already are sitting in the right position. So we can say these are the same, And we can also say those are the same, and those, and these. So we can list them all out, but hopefully now this sketching is clear to you about what this means. When I put these three lines there, it means the measure of AC equals the measure of DF, and AB equals DE. And because for congruence in line segments all you need is equal measure, this also means line segment AC is congruent to line segment DF, and line segment AB is congruent to line segment DE, and so forth. Okay, so there are 5 ways that you can state as a reason that 2 triangles are congruent. You may only use the 5 theorems below, none others, and you may only skip at most one angle or side as you go. So side, 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 which we write SSS, means all the sides are equal from one to the other. So if I could have turned it this way and had 1, 2, 3, and that still would have been fine, but they just have to go in order. Side, angle, side. That means side, included angle, side. That those have to match. Side, included angle, and side. So 2 sides and the angle that they make. Angle, side, angle means 2 angles and their included side have to be the same. Angle, angle, side, oh, we've lost something there. Whoa. Angle, angle, side means 2 angles and then a side other than their included side. So it could have been this one or it could have been this one. It doesn't matter. It's just one that's not included. An hypotenuse leg, once you say hypotenuse, you're claiming that it's a right angle. There isn't such a thing as a hypotenuse in other types of triangles. So hypotenuse leg means the hypotenuse is the same and one of the legs is the same. And thanks to Pythagoras, we know that we could determine the other side based on those 2, so it's basically a special situation of side, side, side. Okay, so side, side angle was not listed before, and neither was angle, 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 and they're not good enough. If you have side, side angle, so you don't have the included angle, you have a separate angle, then there are basically 2 ways to create the triangle. So if I fix the side that's next to the angle and the angle, if I just had a side length to come from this point, it could either go this way or this way. And that makes 2 different triangles. So this isn't enough control. There are 2 possible results. The angle, 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 there are infinitely many options now. So fixing the angles, you could blow it up and shrink it, and it would always still have the same angles, but it would have different sides all the time. So that all kinds of doesn't work. With the first one, side, side angle, if you knew they were both obtuse or you knew they were both acute on a given angle, on that last angle, then you could be certain they were the same. Okay, so we want to decide if any of the theorems prove the triangles are congruent. So in this one we have 2 sides marked 1, 2 sides marked 2, 2 sides marked 3. So we have side, side, side as evidence that these are the same. And if I have A, B, C, AB, this thing is basically upside down. So if I move this around so that it looks like this, then it would be rotated, and X would be on top, Y, so X, Y, Z. You could check by saying A and B need to be with X and Y, B and C need to be with Y and Z. So you know that these two have to be YZ and these two have to be XY. So if you wrote YX, then you're in trouble because you can't make the YZ. But if you can rotate it in your mind, that's the easiest way. Here we have two angles that match, and they're included side matches. So that's angle, side, angle. And A is the same as U, so U goes there. B is the same as V, so V goes there, and then it's T at the end. This one has side, side, angle. So this one we can't because we don't have the included angle, and remember that side, side, angle is not one of the options. And you can't ever trust an image for the scale. So this could be going this way. This one could be going this way or this way, and we don't know. Okay, so this one we have angle, angle, side, the thing about two angles is if you have two angles, you have all the angles because they add up to 180. So two angles is more useful than two sides. So angle, angle, side, angle, angle, side, and it needs to be the side that's next to this angle and not this one, because in both cases. So the side that's marked 1 for the angle, angle, side to be accurate has to be the one opposite the double, and it is. So if I were to rotate this around, I'd have to flip it over 2, but the angle, angle part helps us. So A goes with K, C goes with I, so B must go with D. This one, very little is marked, but we do know these are the same. So the question is, do we know anything else? We know these two are the same. We know these two angles are the same. And because these two lines are parallel, we have something called alternate interior angles, I think is right. But I think we talked about this before. I hope we did. If you imagine this line extended, and these two are parallel, then these are equal. So these are equal, and that gives us angle, angle, side. So we can use angle, angle, side after we do a little more. It wasn't necessarily obvious. So angle, angle, side. So angle A goes with angle H. Angle B goes with angle G. And angle C goes with itself. It's the different angle, but in the HGC triangle, it's this one, and in the ABC triangle, it's this one. Okay, similarly on these, well, this is a parallelogram anyway, so you know these are the same. And you know these are the same. Because it's a parallelogram, the opposite sides are the same length. So we have side, angle, side. So angle A in the ABC triangle goes with angle C in the other triangle. Angle B goes with D. And angle C in the ABC triangle goes with angle A in the CDA triangle. Okay, we're given angle, angle, side, side. Because this is isosceles, remember that those are both right. So we have angle, angle, side. So angle A is the same in both triangles. Angle B is angle F, and C is itself in both triangles as well. On this one, we can go ahead and say we have those angles the same. But what we have then is angle, angle, angle. And that is not a theorem. I could keep going way out here, make these very clearly not equal triangles, and these would be the same. This one, we have side, side, which means these angles are the same, remember, because of the opposite. It's the side opposite the angle. So these two are the same. So we have angle, angle, side. Angle A goes with itself again. Angle B goes with angle D, and C goes with itself again, too. Okay, so we've got angle, side, angle. It's the included side. So angle A is the same as D. B is the same as F. C must be the same as E. This one has the vertical angles the same. So we have angle, angle, side. Angle A goes with angle H. B goes with G. C goes with itself. And on this one, this side is definitely the same. So we have side, side, angle. And remember, side, side, angle is not enough. So the thing that we would need is that if we look at this as an isosceles triangle, we would need to know that that was dropping down to be perpendicular. And that's the part we don't know. So we can't know for sure on this one. But with this one in particular, we know that this part has to be acute. The reason it has to be acute is because it's part of this triangle here. So we can say actually that these are the same, but it's based more on these having to be the same. So we wouldn't really put it as side, side, angle so much as side, angle, side. And ABC is congruent to NBC. Okay, so here we're given a theorem and some information, and the question is, what else do we need to know to use that theorem to prove that the triangles are congruent? Okay, so if we wanted to use side, angle, side, we need two sides and their included angles. So we would need to know that angle ABC, which since there's only B over here and not over there, we would need angle B to be congruent to angle Y. And then we would have side, angle, side. If we wanted to use hypotenuse leg, well, we've definitely got hypotenuse. So what we would need to know is one leg or the other. So either that AC was congruent to FB, or that AB was congruent to FC. For angle, angle, side, here's our sides, or here's a side that's the same for sure, so that's given. So we would need angle, angle. So we would need angle B congruent to angle D, and either this one congruent to this one or this congruent to this. So angle BAC congruent to angle ACD, or angle BCA congruent to angle ADC. If we wanted angle, side, angle, we have angle, side, angle, angle, side, angle. We don't actually need anything else because these are vertical angles, so we know they're the same, so we already have it. Side, side, so we need these bits to be the same, so we need BC to be congruent to CD. Angle, angle, side, we've got these angles the same, and we've got this side the same. So we need angle, angle, side. Angle 6 needs to be the same as angle 1. Okay, so we want to draw and label congruent triangles and find what's missing. So we have LMN and OPR. So LMN, OPR. We need to remember to do it in the same order. So the measure of L is 29. So that's 29, which means this is 29. P is 66, which means M is 66. N is 4x plus 53, which means so is R. Okay, so here's one thing. First of all, the measure of R, we can, I don't know why I wrote B, R, we can take 180 minus the stuff we already have, 29 plus 66. So this altogether is 95, so this is 85. So the measure of R is 85, which means N is also 85. So 4x plus 53 is 85. Subtracting 53, 4x is 32, x is 8. Okay, we have ABC congruent to RST. AB is 14, which means RS is 14, because AB and RS are in the same positions. BC is 17, So ST is 17. And that's what we were asked. TS and ST are the same. So 17. ABC is congruent to EFG. AB is 8. That means EF is 8. And we're asked for FE, which is EF. So that's 8. 4x plus 10 is 8. 4x equals minus 2. X is minus 1/2. LMN and OPR again. LM, which is also OP, is 10 less than 3N. LN, which is also OR, is 2 less than twice N. And PR, which is MN, is 5 more than the number. OP is 4 more than N. And we want to find LN and OR. Okay, so we have that these are the same, so we can solve for N. Add 10. Subtract N. So N is 7. So LN is 2 times 7 minus 2 is 12. And we want OR, which is the same. So 12. I'm going to take a pause here and maybe do the proofs part as part of another module. Trying to get this module done for you as quickly as possible, so I may skip over to similarity and come back to this. Okay, so I want to go ahead and talk about similar triangles, and then after similar triangles we'll talk about some things with right triangles, and then we'll call this module a day until I get some exercises up there for you. So similar triangles are not quite congruent, although congruent triangles are similar. But similar triangles are shaped exactly the same, but they might be larger or smaller. So congruence you get when you basically have those rigid transformations like translations and reflections or rotations. And similarity can include dilations as well. So this is first just a little review of proportions. So we're trying to figure out if they're true. If two fractions are equal, then you can cross multiply and it's equal. So the question here is 10 times 12 equal to 6 times 20? So it's cross like that. 120, 120, yes. To check this one, is 7 times 7 equal to 6 times 8? 49, 48, so no. Is 30 times 2 equal to 5 times 12? 60, 60, yes. So we want to complete this using this. So we're given 4 over 6 is 2 over 3, which is of course true. But what does that mean about 6 over 4? Well, if I flip this one upside down, I just flip that one upside down. And then the proportions are the same. I still get 6 and 2 and 4 and 3, 6 and 2, 4 and 3. 2 over 4 is 3 over 6, because these two are related in the same way that these two are. And 4 times 3 is 6 times 2. Similarly, if I have r over s is x over y, then I can first of all say s over r is y over x. And I can also say that x over r is y over s. And I can also say that s times x is r times y. So you get actually a lot of handy relationships if you know a proportion. Okay, so if 9 over y is 4 over 5, then 4 times y, so, oops, let me get a pen so I don't skip pages there. Maybe a different color. Let me rewrite this in the way it was. 9 over y, that color is not good. 9 over y is 4 over 5, then 4 times y, so these two times each other, is 9 times 5, is 45. We want to find the ratio of x to y now. So 10x is 17y, so let me rewrite this again, x over y, so y got multiplied by 17, so 17 and y should be opposite. X got multiplied by 10, so x and 10 should be opposite. Okay, again, x got multiplied by 43, so 43 is in the denominator. Y got multiplied by 8, so 8's in the top. Okay, so this time 2x over 3y equals 5 over 3. So this is back to stuff you've done before. If I want to get rid of this 2 over 3, I need to multiply by 3 over 2. And I get 5 halves. Okay. So we have a mixture of concrete, and the ratio of cement to sand is 1 to 4. So cement to sand is 1 to 4. How many shovels of cement are needed to mix with 80 shovels of sand? So C over 80 equals 1 over 4. I've just replaced sand with 80. So that means 4 times C equals 1 times 80. C is 20. 20 shovels. On a map, 1 inch represents 100 miles. Find the actual distance between two towns. So let's see, for map mile, we'll use P. I'm just taking the other letter in map that's not in miles here. I mean, A would be weird. Map to real miles, I guess I could just put M, is 1 to 100, 1 inch, 100 real miles. So 5 and a quarter inches apart, 5 and 1/4 is what? So 100 times 5 and a quarter equals 1 times m, or the number of miles, so 525 miles. We have two complementary angles, which are 7 to 11, which means 7 times something and 11 times something, so 7 times something plus 11 times the something equals, they're complementary, C is in corner, so they equal 90. So that's 18x is 90, so x is 5. So that means that the angles are 7 times 5 and 11 times 5. Okay, so a dilation creates similar figures, as I mentioned to you. If you look at these two, they have all the same angles. Remember I mentioned before with the angle thing that you might get something that's a blown up version of the other, so that's a dilation, so that's acceptable for similarity. So the angles are all the same, so they're similar. And in this one, the angles are all the same, 34, 162, 81, 83, so they're similar. These two are not similar, but the angles are the same, but this isn't a triangle. Okay, so with a triangle, angles are enough. With an object like this, you've got a bit of a problem because you can stretch it in one direction and not the other and keep the same angles. So here, what must have been the difference? So if we look up here, 9 and 6 are related in a 3/2 ratio, 6 and 4 are 2, 12 and 8 are 2. Here, 2 and 2.25, so that's adding an 8. 3 and 3.75 is adding 3/8. Oh wait, 2 goes to 1.5. I need to arrange myself here. 2.25 goes with the 3. Because that's the one between the 81 and 83. So 2.25 over 3. Let's multiply it by 4 to clean ourselves up. So that's 8, 9 twelfths, or 3/4. And 1.5 goes to 2, 3 over 4. 6 over 8, 3 over 4. 3.75 over 5, if you multiply each of those by 4, then you get 15 over 20. So again, you get 3/4. So the difference is the proportions are the same. Here, 2 over 2 is 1. 8 over 4 is 2. So we don't have a proportional relationship. So side lengths, well, what we notice about the angles is they're the same. But that's not enough, or these would be similar. So if we do the ratios comparing everything, then we notice that they're proportional. Which is to say, between the two figures, the proportions are always the same. So two polygons are similar if and only if angles are congruent and sides are proportional. Okay, so we can write a similarity statement, and remember that congruence also adds an equal sign. So in congruence, they're not only similar, but actually the same. So similar means this, it could have been blown up business. A is 55, F is 55, so F goes first. B is 64, E is 64, so E goes next. C is 61, D is 61, so D goes next. Okay, so we want to decide if these two things are similar. This is 90, that's 90. This is 53. These two have to add up to 90. So this one has to be 37. That's 37. This is 53 for the same reason. So the question is then, are they proportional? So is 28 over 32 equal to 21 over 24 and also equal to 35 over 40. This one reduces to 7/8, so does this, so does this. So yes, they are. Their similarity ratio is 7/8. The similarity statement is that SRQ is similar to, S was the 90, so Z goes first. R is the 37, so U goes next, X. Okay, so these two are both rectangles, so we don't have to check anything about angles. They definitely have all the same angles. So the question is 18 over 24 equal to 36 over 54? This one reduces to 3 over 4. This one, let's see, 18 over 27, so 2/3. So, no, because the sides are not proportional. Okay, so we are told now that ABCD and RSTQ are similar quadrilaterals. So we know that. So AB, which is 10, over RS, which is Z, is equal to AD, which is 8, over RQ, which is 6, and is also equal to DC, which is X, over TQ, which is 12, and also equal to, what have I missed? I've got BC, which is 6, over ST, which is Y. So 8Z equals 6 times 10. Z equals 60 over 8, or 15 halves. Eight times 12 equals 6 times X. So on the first thing I used these two, now I'm using these two. Dividing by 6, I get X is 16. Because dividing 12 by 6, I get 2, so 2 times 8. And 8 times Y equals 6 times 6, so Y equals 36/8, which is 9 halves. Now, once I had solved for Z, I could have used this one with X over 12. Once I solved for X, I could have used these two together. It really doesn't matter, you're going to get the same answer either way. Okay, so now we're given that CGB is similar to RPS, and we want to find the values of X and Y. So we know that CG, 36, over RP, X plus 5, equals CB, 30, over RS, 20, equals BG, 24, over PS, 5Y. Okay, so this one equals 3 halves, so let's simplify our lives right there by that. So 36 times 2 equals 3 times X plus 5 equals 3X plus 15. So 72 minus 15, 57, equals 3X. X equals 19. Three times 5y equals 2 times 24. So 15y equals 48. Dividing by 15, this is 16/5. So 3.2. Okay. The town of Goodland, Kansas claims that it has one of the world's largest easels. It holds an enlargement of a Van Gogh painting that is 24 feet wide. So I'm just drawing a picture to keep things straight. The original painting is 58 centimeters wide and 73 centimeters tall. If the reproduction is similar to the original, what is the height of the reproduction, so h, to the nearest foot? So we have that 24 feet over 58 centimeters equals h over 73 centimeters. 58 centimeters times h equals 24 feet times 73 centimeters. So we can mark out centimeters on both cases, and we'll just have feet left. So h equals 24 times 73 over 58 feet. And then you would put that in your calculator and round it to the nearest foot. Okay, so now we have that if two angles are the same in a triangle, then the triangles are similar, because if we have two angles, then we have three, right? So we only need two. So if two angles of one triangle are congruent, to two angles of another triangle, then they are similar. So 62, 44, and 74, so they're so far not similar by angle, but 62 plus 74 is 136, leaving 44. So if we go ahead and solve for that one, then they are. 50 and 75, 45 and 75, 45 plus 75 is 120, so this one's 60, not 50, so no. Side angle side similarity is good enough, so side angle side is good enough for similarity. So if two sides of one triangle are proportional, and the included angles are congruent, then the triangles are similar. So if you have two sides which are proportional and the included angle is equal, then you get SAS. So we have these angles. So if these two sides are proportional, that's enough. So is 8 over 6 equal to 6 over 4? This one's 4/3, this one's 3/2. No. 25, 25. So is 18 over 6 equal to 15 over 5? 3, 3. Yes. The side-side-side similarity theorem says if three sides of one triangle are proportional to the three corresponding sides of another, then they are similar. So we've got to check, because we don't have any angles at all, we have to check every side against every other side. So is 18 over 12, and I'm just going to start with the smallest one so that we don't have to figure out how to rotate it or anything. Do the smallest ones first, the next largest ones next, and the largest ones last. 3 halves, 3 halves, 3 halves. Yes. So over here, again, smallest first, so 3 over 2. Does that equal, let's see, I guess 8 goes with that one. 8 over 4, and does that then equal 9 over 6? 2, 3 halves, no. Okay, so we want to decide if any of these 3 things can prove similarity, and if not, we just put not similar. So side angle side, that is very odd and should be down there and not up there. So these two have this included angle. So if these sides are proportional, then they're done. We only have 2 sides, so it can't be that. We're only given 1 angle, so it can't be that. So this is our only chance. So is 16 over 8 equal to 12 over 6? 2, 2, yes. So they have side angle side similarity. This one has angle, angle, and because of the vertical angles, these 2 angles. So yeah, angle, angle. This one has all 3 sides and no angles at all, so it definitely can't be those. So we're looking for this one. So is 4 over 2 equal to 6 over 3 equal to 9 over 4.5, 2, 2, 2. Similar. Okay, here we have side angle side, only we don't have that directly, right? We have this angle. We don't have this one listed. So because it's isosceles, we know that these 2 are the same. So this one's 74. So 74 plus 74 is 148, leaving 32 degrees to be up there. So now we have side angle side, side angle side, if these are similarly proportional, but because these 2 are the same and these 2 are the same, 5 over 4, 5 over 4, then of course they are. So side angle side. Okay, here we want to find the value of x. And we've got, these are the same. Because of this parallel, we have these are the same. And those are the same. So the proportion goes with these 2 together and these 2 together. Because x is included between the first and second angle, 9 is included between the first and second. So x over 9 equals 8.75 over 7. So 7x equals 9 times 8.75. I'm going to multiply through by 4 over 4 to make this nicer. So we have 9 times 35 over 7 times 4, and that cleans up and we get 45/4, which is 11.25. Okay, so this one, again, we have this the same. Okay, so 20 over x plus 9 equals 15 over 2x minus 2. So 20 times 2x minus 2 equals 15 times x plus 9. I'm going to divide through by 5, so make that 4, make that 3, and then distribute. 8x minus 8 equals 3x plus 27. Adding 8 over here, I'll have 35. Subtracting 3x over here, I'll have 5x. X is 7. Okay, so whenever you see triangles like this, if these two are parallel, then you will have similar triangles, being the big one and the little one. So we need to find out in this case. So is 5 over, that's this one, 15 is the whole thing. Is that equal to 3 over 9? And yes, because they're both a third. So triangle SRT is similar to triangle PRQ, and it's by side angle side. Because of course the angle is exactly the same. Okay, so this one we need to check proportionality again. So our only opportunity is maybe SSS. So we want to take the smallest, 12, over the smallest, 16. Next one, 16 over 20. Next one, 18 over 24. This is 3/4. This is 4/5. And this is 3/4. So this one makes them not similar. And I guess I'll just leave the SSS as the reason it was not. Okay, so this one we maybe have side angle side. Oh, except we don't because we have the opposite side. So we could solve for it using Pythagoras. So we have, let's solve for this one. 4 squared plus MO squared equals 15 squared. 16 plus MO squared equals 225. MO squared equals 209, which is not a perfect square. And if these were similar, 4 to 8 is a doubling. So this one would have to double to get to 30, which actually means this one would need to be 15, which it can't be because the hypotenuse is. So not similar. And we were trying to do it by side angle side. And we are not proportional. This one, we've got side, side, angle. And what we need is then proportionality. So is 10 to 10 equal to 3 to 3? And the answer is yes, they are similar. Angle DEF similar to DHK. Okay. So we're given this angle for sure. 18 over 12 is 3/2. 12 over 8 is 3/2. So these are similar. So 8 over 12 is equal to 16 over x. This is 2/3. So 2x is 3 times 16. 2x is 48, x is 24. These are parallel, so these are definitely similar. So we have 16 over x equals 12 over 10. So this, if you want, is 6/5, but 160 equals 12x. So dividing by 12, we get 80 over 6, 40/3. This one, these two angles are the same, these two angles are the same, so these sides are the same, so 8 over 12 is equal to 7 over x, and this is 2/3. So 2x equals 3 times 7, x equals 21/2. Okay, this is 8, this is 8, 24, 24, angle, angle. So these are similar. So we have that x over 8, and I'm using this 8 here, is x plus 14 over 24, because this entire length is x plus 14. So 24x equals 8 times x plus 14 equals 8x plus 112. So subtracting 8x, 16x is 112, x is 7. Over here, we've got 50, 50. These angles are the same too. So these are similar. So if I take the two around 50, or the one between 50 and the other given angle, 8 and x go in the same spot. And then just touching this angle, just touching this one is 5 and 10. So 5, 10. So that means that this is a doubling situation. So 80 equals 5x, 8 times 10, 5 times x, so 16 is x. These are the same. 18 over 6 is 3, 24 over 8 is 3, so these are similar. So we can say 24 over 8 equals x over 4. So 24 times 4 equals 8 times x, and dividing that by 8, x is 12. Over here, these are the same. These are the same, so we've got angle, angle, similarity. X is the hypotenuse. These two lengths go together. So 120 over 8 equals x over 15. Dividing by 8, let's see, 120 divided by 8 is 15. So x equals 225. Okay, that brings us to right triangles, and my brain is obviously getting sluggish, so I'm going to take a little break here and get back to that shortly.